Hello children, today we will be learning the chapter circle as per the demand of the children. So we shall learn the chapter circle. Before we start, let us revise some basics of circle. Now as we are going to learn circle chapter, so let us know what a circle is. Everybody know it, but just revise it. A circle is a set of all points. Circle is a set of points from a fixed point. This point is a fixed point and these are the set of points. When they are joined, they create a circle. Now, what is a radius? So, fixed point is known as, fixed point is known as center. And if we join this fixed point to any point on the circle, this makes a radius. The fixed point, that is center. If we join the center to a point on the circle, this will make a radius. Now, if we take 2 points on the circle and join those 2 points, suppose this is point A and this is point B. If I join these 2 points, this is known as chord. Now there are so many chords. A line which passes from the center and join 2 points on the circle. These are the 2 points on the circle. Suppose this is P and this is Q, and this is the line which is joining point P and Q. Point P and point Q are on the circle, and the line which join this point P and point Q is passing from the center, and this is known as diameter. Radius is half of diameter. Radius is half of diameter. Diameter is also known as the longest chord of circle. Diameter is also known as longest chord of circle. Now we have discussed chord. 2 points are there on the circle. The line which join this 2 points is known as chord. Now which is the longest chord? The line which joins the 2 points but also passes from the center. That is known as diameter, and that is only the longest chord of a circle. Now let us go for a secant. Now I said that there are 2 points which are joined by a line that is known as chord. So if these are the 2 points, suppose say S and R, and if a line is passing from these 2 points and cuts the circle, see it is going beyond, this is known as secant. It is called as secant. Now let us go for another point. This is the circle and this is center of the circle, and there is one point on the circle, say as M. If a line passes from that point and that line just touches the circle, what is it? This is nothing but tangent. A tangent is a line which passes from one point on the circle and only touches the circle. That is known as tangent. Now in 9th standard you have learned so many things. Let us revise them. Suppose this is the tangent. If I draw a line, this is the line which join the point M on the circle and center. So this is going to be a radius. But at the same time, a line is passing from the point M which just touches the circle. So this is going to be perpendicular. Radius is always perpendicular to tangent. Radius is always perpendicular to tangent. OM is a radius and L is the tangent which is touching the circle at point M. So OM is perpendicular to tangent. Now we have also learned in 9th standard, that is, if a chord, let me draw a circle here. Suppose this is the chord and let me label it as AB. O is the center of the circle. I said radius is always perpendicular to a tangent. A line drawn from the center to the chord, a line drawn from the center to the chord and which joins the midpoint of the chord is always perpendicular. Suppose M is the midpoint, so OM is going to be perpendicular to AB. M is midpoint, then OM is perpendicular to AB. Since M is the midpoint, so AM is equal to MB and therefore OM is perpendicular to AB. And if OM is perpendicular to AB, then M will be midpoint of the chord. See, if a line is drawn from the center and it joins the midpoint of the chord, then that line will be perpendicular to the chord. And if OM is perpendicular to the chord AB, then M will be midpoint. These two things or two concepts you have learned in 9th standard. Children, now we will see in a circle, or if the circles are congruent and the chords are equal, then those equal chords are going to subtend equal angles at the center. Angles at the center. Let us see. I am drawing a circle. Now this is called AB and this is called PQ. There is a chord AB and there is a chord PQ. This is center O. If I join it, AB is equal to PQ given. Now what happens? AB will subtend angle at the center, that is AOB. AB subtend. Subtend means AB makes an angle at center O. AB makes an angle at the center O. So we call it as subtend. AB subtend an angle an angle AOB at center and PQ also subtend. This means subtend an angle POQ again at center. Subtending means it is making an angle. Okay, so this is the angle which is subtended by PQ at the center. This is the angle, this angle AOB subtended by chord AB at the center. So what is the relation between these two angles? These angles are going to be equal. Angle AOB is equal to angle POQ. So chord AB is equal to chord PQ. Chord AB have subtended angle AOB. Chord PQ have subtended angle POQ. They are going to be equal. Why? Because the chords are equal. Now second statement is, now this is the circle, or if two circles are there, two congruent circles are there, if two chords subtend angles at the center, not equal, if two chords subtend angles at the center, correct, equal. If two chords subtend equal angle at the center, then the chords are equal. Now earlier we saw that two chords are equal and therefore angles are equal. Now what is said? Two angles are equal and therefore the chords are equal. Now see, AB is subtending angle AOB, PQ is subtending angle POQ, but these two angles are equal. Given angle AOB is equal to angle POQ, given, okay, and therefore we can say chord AB is equal to chord PQ. Chord AB is equal to chord PQ. See here, angles are equal, therefore the chords are equal. In a circle or congruent circle, if two chords which are equal, means chord AB is equal to chord PQ. It is given here. If two chords are equal, then they will be at equal distance from the center. So we can say O is the center, M is the point between AB and N is the point between PQ. Since chord AB is equal to chord PQ, so we can say OM is equal to ON. That means they are at equal distance from the center. This you have learnt in 9th standard, children. Now you want, we can prove it also. Just for a revision, see, I have to join the line OB and OQ. Now I need to prove these two triangles equal. Now before this only I have discussed with you a line drawn from the center to the chord, to the midpoint of the chord is perpendicular to the chord. So we want to prove OM is equal to ON. We can prove it easily. See here, angle M is equal to angle N, which is 90 degree. OP is equal to OQ, radii of the circle. MD is equal to NQ. Since chord AB is equal to chord PQ. Now, if M is the midpoint, then half of AB is equal to half of PQ. Now what is half of AB? MB is equal to what? Half of PQ, what is NQ? And therefore we got MB is equal to NQ. Now see, in this triangle, this is the first point, second point, third point. After this we can write down triangle OMB is equal to triangle ONQ. And the reason for it is side angle test. Side angle test. And therefore we can say OM is equal to ON. That is congruent side of congruent triangle. And that is what the statement is. If the two chords which are equal, then they will be at equal distance from the center. And we proved it. This we have done in 9th standard. It was just a revision for you. In a circle, the chords which are at equal distance from the center are congruent. This is there in 9th standard. In detail you will be getting in 9th standard video how to prove it. It is just a revision. So suppose O is the center of the circle and I draw this line ON and here one line ON. So if ON is equal to ON, that means chords which are at equal distance, means OM is equal to ON, equal distance from the center, then the chords are equal. Chord AB is equal to chord PQ. Since AB and PQ are at equal distance from the center and therefore they are equal. Children, you can see two circles at the board, and the center of this circle is O. Let us take this center as P. So OM is equal to PQ. Suppose OM is equal to PQ. What is OM? OM is the radius and PQ is also radius of the circle. So what is the relation between these two circles? These circles are going to be equal since their radii are equal. Concentric circle. Now see here, this is the center O. There is one circle. Now if I draw one more circle, there are two circles, the same center. Center is same but radii are different. Why I wrote radii? Radius means 1 and radii means more than 1. So here there are two radii. For smaller circle, the radius is ON, and for the bigger circle, the radius is ON. But these two circles are said to be concentric. Why? Because they have the same center. Since they have the same center, therefore they are called as concentric circle. Touching circle. Circle are said to be touching in two ways. This is one circle I have drawn. Okay. So, now one more circle I am drawing. Now see here, these two circles are touching at the point P. The center is M and the center is N. This circle has a center M, this circle has a center N, but they are touching at one point P. This means these two circles are touching externally. Externally they are touching to one another. Now what is internal touching? If I draw a circle, and one more circle I draw inside. Now here they are touching also at one point, let us say P. The center of bigger circle is M, center of smaller circle is N, but both are touching internally. Suppose I pick up this circle and bring it inside. If this circle would have been smaller as much as this. So this, when it is out, it is touching externally. But when it is coming inside, then it is touching internally. Internally. Intersecting circle. Now see, I have drawn a circle. Before this we saw two circles were touching each other at one single point. But if I draw one more circle and it is in such a way that both the circle are sharing 2 points, point P and point Q, center M and center N, then they are intersecting circle. When they share 2 points, then they are intersecting circle. If they are sharing only 1 point, then they are touching circle. These are touching circle. This is external touching. And if this way it is internal touching. This is internal. But here these are intersecting circle because they are sharing 2 points. Now we will see circle passing from one point. So there can be infinite number of circles which can be drawn, which passes from one single point. So infinite circle can pass from one single point. So if there are 2 points, so you can draw so many circles which will be passing from 2 points. So again, this is point A, this is point B. Infinite circle can be passing from 2 distinct points. 2 distinct points. Remember children, infinite number. So many circles can pass from 2 distinct points. So many circles can pass from one single point. Now we will see if there are 3 points which are non-collinear. So how many circles can pass from 3 non-collinear points? Suppose I draw a circle. Point A, point B and point C. Point A, point B and point C are which point? Non-collinear point. So if I join them, I can create one circle. So that means from 3 non-collinear points, only one circle can pass. A, B and C, there is only one circle which can pass from three non-collinear points. These points are non-collinear. They are not in one line, and therefore one circle can pass through these three non-collinear points. Now you can see on the board there are 3 points, point A, B and C. Now how many circles can pass through these three collinear points? Collinear means they lie in one line. Okay. So if I am drawing all 3 points cannot be on one circle. All 3 points cannot be on one circle. So if I want to have all these 3 collinear points on one circle, it is not possible. I can draw many circles from these 3 collinear points differently, considering each point as an individual point. But all 3 points cannot be coming on one circle. There is a circle with center O, and there is a line which is passing from the point N. So what is this line? I have discussed in the beginning only. This line is going to be a tangent. And this tangent is, ON is a radius. This tangent is going to be perpendicular. So a tangent is always perpendicular to the radius. Tangent is perpendicular, this is the sign of perpendicular, to radius. Now, if it is a tangent, it is going to be perpendicular to the radius. Tangents drawn from an external point to a circle are congruent. This is what we want to prove. So, what is given? And what we want to prove? There is a point P. P is an external point and P A is a tangent. PA and PQ are tangents from point P what we want to prove? Tangents drawn from an external point to a circle are congruent. We want to prove PA is equal to PQ. This is the information given to us, and we want to prove PA is equal to PQ. So what we will do? We will draw a line joining A and O and a line joining Q and O. Construction. Join AO and OQ. Join AO and OQ. AO and OQ. Children, OA or AO is going to be perpendicular to this tangent by tangent and radius which are perpendicular. OQ is going to be perpendicular to PQ. I am also going to join in the middle, OP. and OP. So what are we getting? We are getting one triangle POA and POQ. So let me write P here. In triangle, now this is the solution. In triangle POA and POQ, we will be proving these two triangles equal. If we are able to prove these two triangles equal, then we can say that PA is equal to PQ. It is going to be very easy to prove. See. Now in this triangle, POA and POQ, how can we prove them equal? See, AO is equal to OQ. Now you know, children, why AO is equal to OQ? Because, yes, correct, they are radii of the same circle. Radii of same circle. OP is going to be equal to OP, that is common line, a common segment of both the triangle, of triangles. First point, second point. Now the third point, angle OAP. See, I am on A, so A should come in the middle. I can start from PAO or I can start from OAP. OAP is equal to OQP. Both are equal to what? 90 degree. And why they are 90 degree? Because this is the tangent and this is the radius. Tangent radius. Okay. Tangent is perpendicular to the radius. So we got three things. This side and angle. So I can easily say in the fourth point that triangle OAP is equal to triangle OQP by side angle test. Side angle test. We proved these two triangles equal. So we can easily say that PA is going to be equal to PQ. So I can write here next point, that is fifth point, PA is equal to PQ. Congruent side of congruent triangle. And PA and PQ are nothing but tangent. Hence proved that tangent drawn from the external point are congruent. Children, you can always pause the video and you can write it down. Whenever you watch the video, you must pause and you must write and practice it more than 3 to 4 times each sum. Then only you will be perfect.